Okay, go.
Okay na? Go. So guys, before we move on to the merge sort, first we'll have a bit of a mental game and to test lang how you manage your skills as a student. So now assume na ikaw ay isang avid fan enjoyer of golf, nag-bar, nag-food trip lang. Then 3 weeks pass, then you
Nanigigo ba?
have these things to do. So it's quite cluttered, di ba? Pangit. So now, how will you sort this if you were a student? So ano yung criteria? Ikaw, Fego,
Kanang pinaka-importante.
importante,
Oo.
specify for that.
Kanang unsa ang kailangan na deadline, ang deadline.
May deadline. So,
Oo.
right here, assume na everything has the same deadline. So, wala na yan. So, what is your criteria now?
Ambot.
You know? Proceed tayo dyan. So, here, first we label muna kung ano yung mga subjects dito. So, there are 5 subjects here. So, we have the DSA, Modern World, OOP. Basically, lahat ng subjects natin ngayon for this term. So, now, our criteria here, personally, para sa akin, we should sort them according to type. So, we go from formative and summative, di ba? So we do the easy ones first, which is formatives, then summatives. Ganun talaga sa students, di ba? So now we will sort them according to that, but we will divide them into subsets. So we have the first subject, ito dito. So dito yung Philpop, this is for Modern World, and this is for OP, this is PE, and this is for DSA, okay? So, we have sorted them according to this criteria. So, dito yung mga FA, dito sa summative. So, summative to sila. So, now, as you can see, sorted na siya, ang mga subsets. But here, as we can see, we can still sort them according to the difficulty of the subjects. So, unahin natin yung easy ones, minor sa taas, then major sa baba. So, we will do that. Now, it's sorted by course and with that criteria. Then after that, since na-sort na siya, we can now remove the labels of the subject, and then we sort them as a whole. So lahat ng formatives, which are the greens, mauna lahat. Then the next would be summative. So as you can see, it's already sorted, right? So based on the sorting criteria, so formative then summative. Now by doing that, we did not realize that we're actually doing an unintentional merge sort. So with that in mind, we'll move on.
Hello guys, we will introduce to you what is merge sort. So merge sort is a sorting algorithm, and these are the topics covered for our presentation. Next, we have what is a sorting algorithm? A sorting algorithm is an algorithm that puts elements in a list in an order, just like what we have seen by using the merge sort unintentionally. We put the elements, which are the activities, in the
Categories.
place. So the definition of merge sort is it is a type of sorting algorithm that uses a divide and conquer strategy to sort a given array. Then you may ask, why a divide and conquer strategy? And what is that? A divide and conquer strategy basically it uses recursion in order to split the smaller problems and solve the initial problems similar to that. Now we have our friend here, Nathan, to demonstrate how that divide and conquer works.
Well, in the division part, or the divide part, we first have one large array, and then after that, it splits here, as you can see in the conquer part, but it's part of the divide part. As you can see, it gets split into half. We have a 4-length array here, and after that, it gets split into two, and after that, it gets split into individual pieces. Once it gets split into individual pieces, we start to sort them by their size. For example, if it's ascending, we go from small to big, and descending, big to small, of course. And we do that until it gets fully merged up into the proper array.
Now let's look at the algorithm move in place. So So as what Nathan has explained earlier, as you can see, the arrays would split and then it sorts itself into a bigger array. Now, we have our complexity analysis for MergeSort.
Okay, so in MergeSort, the time complexity is logarithmic because each recursion, it divides it into smaller halves, and the space complexity is linear because it requires additional space, although small. It requires additional space for the temporary subarrays, which you will put the data set into. So overall, MergeSort is a very efficient and stable algorithm to use, especially when using in large data sets. And John will expound more on why the time complexity is logarithmic.
So it's guys, actually linear rhythmic to. Why? Because n, yung O of n is linear, di ba?
Oh.
Linear siya.
Wow.
Kasi yung log of n, logarithmic. So
Wow.
if i-combine mo, if i-merge mo sila, kaya i-merge mo.
Wow, merge mo.
Linear rhythmic!
Wow!
So guys, why is it n log of n? So di ba, you see this, kung di mo makita, sige lang.
Hindi makita.
Oh, di na makita, di ba? Anyway, imagine my 8 like things dito, 8 arrays.
Oh, 8 arrays.
And like, you have, how many steps do you have to take to go to here?
Upat.
No, like, first step, second step, third step. 3 steps! What's the relation with from 8 to 3? Let's think now. Di ba kuwan man siya? If log 2 of 8 is equal to 3, kay 2 to the power of 3 is equal to 8,
Wow.
gets mo guys?
Di wala.
Gets mo? Oh my god, wait sa. Wait sa, let's go back to high school math bet.
Oh, okay.
2 to the power of 3 is equal to 8. Gets mo, di ba?
Oh.
Gets mo.
Oh.
So, we get the logarithm. Log. Oh my god, ang sama ng 8. Sige, sige. Ay, gano'n. What did you tell me? Ay, sorry. Anyway, log, log 2, 8. Makita mo?
Oh.
Okay. Di ba yung 8, it just went here. Yung 2, it just went here. So, ano ba yun? Ano yung nabilin? 3, di
3.
ba?
Oh, wow.
Oh, 3.
Wow.
3 steps. Gets mo?
Oh. Bye. Let's go.
Okay. But how about the linear part? Ano siya? Linear. Because
Linear man siya.
8 values, di ba?
Oh.
8 values. It has to, in the worst case scenario, it has to go through all of this 3 times.
Wow.
3 times. Yan yung log 2 of n. Di ba?
So,
And yung n is yung 8 or yung length ng array.
wow.
Wow! So that's the reason why yung time complexity is linear rhythmic. Kay ma-merge, di ba? Ang linear na
Oh,
time
logarithmic.
and yung logarithmic na time. Well, ano?
Oh, merge sort dyan siya ba eh?
Merge sorted siya. Not just in the sorting algorithm, but in the time complexity also. Oh my God. Alright, it's next.
Nice ka.
So now we'll compare the two fastest algorithms, which is MergeSort and QuickSort, with the exception of TimSort. We compare these two because they're the fastest, so it makes sense to know in what scenarios it is best to use the MergeSort and the QuickSort. So our first comparison will be based on the worst case time complexity. The worst case time complexity of MergeSort is O n log of n, while QuickSort is the worst time complexity of O n squared. So why is MergeSort faster? MergeSort is faster due to how efficient it is in dividing subarrays by 2 or dividing it by 2 constantly. So it means whenever there's a large array, the number of iterations would always be the same because you divide it by 2 every time. While in QuickSort, there are tendencies na ang pivoting niya is on the worst position as much as possible. If ever, it's always on the worst position. Therefore, it will reach to n squared. But there are some workarounds to do it so that the QuickSort will be logarithmic time. The next comparison we have is average case time complexity. Merge sort and quick sort are the same in average time complexity. However, it may differ on the scenarios that we'll put it, especially in considering the size of the data set. For merge sort, for larger data set, as I explained a while ago, it's always constant. So in larger data sets, so you'll expect na parati the same yung time complexity mo. While in quick sort, it's better for smaller data sets due to how pivoting works. It's always faster than binary or like divided by 2. So that's for average case time complexity. For the next comparison we'll have is the
Best case.
memory complexity. As explained a while ago in merge sort, you'll have to make temporary arrays in order to divide them. You divide them, and there's every iteration, it will merge, but then you still have to remember that you need extra space or temporary array, diba? While in quick sort, it uses in-place sorting. So the sorting happens in the array itself. You don't need to create any other temporary array, so it makes sense that it's much more memory efficient. So that's for memory complexity. For the next one is locality of reference. So what is locality of reference? It's about how your system will access data in your memory. So for example, if you store data in memory, you put this data in memory addresses. So your system accessing these memory addresses is the locality of reference. Whenever the memory addresses are far away from each other, it is harder for your system to access them. Diba? So that's the poor cache locality, which is merge sort. That's what happens because in merge sort, you create temporary arrays. So if you create temporary arrays, it will have their own memory addresses. So your system will have to jump to different memory addresses in order to access them. So it's harder, so it's less efficient in accessing memory patterns. For quick sort, it has good cache locality, as I said a while ago. It has in-place sorting, so it will always have the same memory address since you're only using the same array. So it's better. That's it.
Alright, so wait up. Ay, what's man, continue to or dili? Continue guys, tara, come here guys, come here. Okay, I'll do the same thing as yung sa grupo nila Aisha. By height din, sort. So, let's start. Kinsa yung, tallest dito ako? Okay.
Pareho ra mamughay.
Mukuan ta, let's all split by height. Split ta. Split ta ba? Oh, okay, so each of us are individual arrays na. Gets mo?
Oh.
Gets mo? Alright, follow. Next, okay, what are we going to do? We are going to sort. Diba? Alright. So, who is, left to right siya dapat. So, who is taller between me and us?
Si Az.
Who? Ay, si Az?
Oh.
So, paano siya? Change. Who is taller between Luis and JL?
JL.
JL. So, as is siya. Who is taller between RG and Nathan? Nathan. So, change sila. Alright. Now, mag-merge ang first two arrays. So, who is taller? Si Luis, si Nathan, or si RG?
Kinsa?
No, I'm asking you.
Si Nathan.
Si Nathan. Who is taller between RG and Luis?
Si Luis.
Si Luis. So Luis will go between RG and Nathan. And then si JL, is he the tallest out of them all?
Oh.
Oh, so she'll go last. And then finally, the two of us, mag-merge kami with the remaining array.
Oh.
Where will you fit in? Ako, I'll go here. Sorted na kami or what?
Sorted na lang.
Sorted na. And that's how you do merge sort. Thank you so much guys.